So, when we talk about software containers, there's one name that's dominated the scene for years. But what if? What if the very thing that made it so popular was also its biggest flaw? That's what we're digging into today. We're looking at Podman, a tool that's challenging the old way of doing things by asking a really simple but powerful question. Can we get all the power of containers, but with better security and way less complexity? Let's get into it. All right, first things first, let's cut through some of the jargon. I mean, you've probably heard all these terms flying around: Kubernetes, Docker, Runk, CRIO. It's a lot, right? It can get pretty confusing to figure out what's what. So, before we dive deep into Podman, let's just take a quick step back and map out the entire container universe. It'll help us see where everything fits. The best way to make sense of all this, really, is to think about it in three different layers. Once you get these layers, you'll see exactly where a tool like Podman slots into the whole picture. It just clicks. So here are the big three. You've got your container orchestrators, your container engines, and your OCI container runtimes. Think of it like a stack. Orchestrators at the very top, runtimes way down at the bottom, and the engines, well, they're sitting right there in the middle. Each one has a really specific job, so let's break them down. Okay, at the very top, you have the orchestrators. The best way to think about these is like the air traffic control for your apps. They're not actually flying the planes, that's not their job. But they are coordinating the entire fleet. They tell the container engines where to launch everything, making sure your applications are spread out across a bunch of different machines for reliability. And yeah, when you hear orchestrator, you're probably thinking of the big one, Kubernetes. All right, now let's jump all the way down to the bottom layer. This is where you find the runtimes. These are the real blue-collar workers of the container world. They're the ones doing the actual heavy lifting, you know? They get direct orders to talk to the Linux kernel using features like cgroups and namespaces to actually build that isolated little box we call a container. A tool like Runk is the classic workhorse down here. And that brings us smack dab into the middle, the container engines. And this is our focus for today. This is the layer that you, as a developer or a sysadmin, actually interact with day to day. So anytime you're typing a command to build an image or run a container, yep, you're talking to a container engine. It's your main interface for managing containers on a single machine. Okay, so now we've got the lay of the land, right? We know where everything fits. So let's zoom in on Podman itself. What exactly is it? And maybe even more important, why does it exist? What problem was so big that someone needed to build a whole new tool to solve it? You know, this quote from Daniel Walsh, Podman's creator, really just nails it. Podman wasn't built just for the sake of having another choice. Nope. It was a direct answer to a huge security problem with the old school container setup. The whole idea of this one giant centralized process, running as root with keys to the entire kingdom, well, that just didn't sit right with him. And for good reason. And you can see that thinking baked right into its official description. It's called a daemonless container engine. That one little word right there, daemonless, that's the whole ballgame. It's the key difference. It's the architectural choice that completely changes how Podman operates. And here's the really clever part. The Podman team made it ridiculously easy for people to switch over. They designed it to use the exact same commands as Docker. So for a lot of developers, getting started is literally as simple as creating this simple alias. That's it. It's kind of like swapping out the engine in your car. From the driver's seat, all the controls feel the same, but underneath, it's a totally different beast. So we keep saying daemonless, but what does that actually mean? Like in the real world, how does it change things? Let's pull back the curtain and really look at how this new architecture works. This comparison really lays it all out. On the one side, you've got the traditional daemon model. Every single command you run has to go through this one central service, which is usually running as root. That's a huge bottleneck, and frankly, it's a massive security target. If someone compromises that one daemon, they basically own your whole system. But then, look at Podman's model. There is no central daemon. There's no middleman. When you type a command, it just runs. It launches the container directly, like any other normal process on your Linux system. It's simpler, and there's no single point of failure. Now, to really get why this daemonless architecture is such a big deal, it helps to take a quick step back. Let's just do a quick refresher on why containers are so darn efficient to begin with, especially when you compare them to the old way of doing things with virtual machines. Okay, so with virtual machines, or VMs, you've got all this heavy baggage. I mean, look at this. Every single application has to run inside its own complete operating system. You've got the app, its libraries, and a whole Guess OS with its own kernel. You're literally running a computer inside of a computer. It's bulky, it's slow to boot up, and it eats up a ton of resources. But containers? They're a whole different ballgame. They just throw all that extra weight out. All the containers share the same operating system kernel, the one on the host machine. They only package up the bare essentials they need to run. And that's the magic right there. That's what makes them so incredibly lightweight and ridiculously fast. And that efficiency is everything. We're talking about applications starting in milliseconds instead of minutes. It's a night and day difference. It means you can cram way more applications onto a single server. And honestly, this speed and density is what made the whole cloud-native and microservices revolution even possible. Okay, so let's bring this all back to Podman. Let's connect the dots here. We're going to see how that container efficiency we just talked about, when you combine it with Podman's secure, daemonless model, creates the perfect launchpad for the whole microservices world. So, this is what the old world looked like. We called it the monolith. You've got your web server, your database, all your application code, everything, all tangled up into one giant single application. The problem? If you wanted to update just one tiny part of it, you had to take down and redeploy the whole thing. It was slow, it was clunky, and it was super risky. And then there's the new way, microservices. Containers let us just smash that monolith into little pieces. Each part, the web front end, the user database, the payment service, gets to live in its own neat, isolated container. They all talk to each other over the network, sure, but they are totally independent. And this approach, it's a total game changer for developers. Think about it. The database team can push an update whenever they want, and it won't break anything for the front-end team. You can use the best tool for the job. Maybe one service is written in Python, another one in Go, no problem. And if one little piece happens to fall over, it doesn't bring the whole house of cards down with it. It just makes everything more flexible, more resilient, and way easier to scale. And this is exactly where a tool like Podman really shines. By just getting rid of that central, all-powerful daemon, it offers a much simpler, much more secure foundation for this modern world of distributed apps. It starts treating containers not as some special, scary, privileged thing, but just as a normal part of the operating system. And that is a huge step forward for both security and simplicity. Which, of course, leaves us with one big question to chew on. As our applications get more and more spread out, and as security becomes, well, more critical than ever, is this daemonless approach that Podman pioneered actually the future? Is this focus on simplicity, on security, on just being a good Linux citizen, is that the new gold standard for how we should be running containers? Definitely something to think about.